All right, so now we are going to be looking at 3.6, which is going to talk about perpendicular bisectors. We kind of touched on this section not that long ago, talking about perpendicular distance and how that's the shortest distance between a point and a line. We will circle back to that as well. So thinking about the word perpendicular bisector, let's break that one down. We've got perpendicular, which we've seen before, and we have bisector, which we have also seen before. So think about those two words. What do they make you think of? Well, perpendicular, what do perpendicular lines create? They create right angles. And bisectors, well, let's see. We've talked about that before. I think bisectors are something that like cuts something in half. So if we're talking about line segments, where does like the bisector occur on a line segment? We have a special name for it, and I think that name is midpoint. So we're dealing with the midpoint and right angles. So how are we going to find this perpendicular bisector? Well, we have the tools we need. You know how to find midpoint. You know how to find perpendicular slopes. So let's see what we can do. So starting off, I want to find my midpoint. So I take my 2 points that I'm given. I have A and I have B, and I'm going to add together the x's. So I have -3 plus 4 over 2, and then I have 3 plus 0 over 2 for my y's. Now let's work that out. -3 plus 4 gives me 1 over 2, and 3 plus 0 gives me 3 over 2. And if you prefer decimals to work with this, that's totally fine. So I can turn this into a decimal real easy. 1/2 can be rewritten as 0.5. And 3 over 2 could be rewritten as 1/2. So let's see where this midpoint is. I've got my graph up here. I'm going to go 1/2 on my x's and then up 1.5 approximately. And this is where my midpoint is. Midpoint. So this is where we are going to intersect with our line when we create our perpendicular. But we have a few more steps to go. So first I need to find the slope of the line that's given to me. So since it's graphed, I can just do rise over run, or you can do slope formula. Either one works. I'm just going to do rise over run since the graph's right here for me. So going 1, 2, 3 down. So if I'm going down 3, that means I have a negative change in my y. And then over 1, 2, 4, 5, 6, 7 to the right. So over 7. So my slope is -3 over 7. So since we are doing perpendicular, this means I need to use the opposite reciprocal. So my perpendicular slope, I'm going to flip that -3 over 7 and change the sign. So my perpendicular slope is 7 over 3, and it's positive. And then I'm going to use that midpoint, and I'm going to write an equation. So we've got, remember, point slope, y minus y1 equals m x minus x1. We just did this, I promise. So we take that midpoint, that's going to be our point, which is at 0.5 and 1 over 5. And actually for this, you might prefer it to be in a fraction form. It doesn't matter to me at this point, but if you end up going to slope-intercept form, it's going to be easier to multiply with the fractions than it is to a decimal in a fraction. Okay, so we've got y minus 3 over 2 equals our slope 7 over 3, parentheses, x minus 1/2. So that is our equation for our perpendicular bisector for the line segment AB. We have y minus 3 over 2 equals 7 over 3, parentheses, x minus 1/2.